Our goal today is to graph equations that represent functions. Before we can graph the equations, there's a couple of things we have to review. First of all, we need to remember that when we have an ordered pair, it's talking about a location on a coordinate system. And when we write that ordered pair, it's always in parentheses. Your x variable is always listed first. That's your distance from left to right of 0. And your y is always written second. That's your vertical distance up or down from 0. Second thing I want to review is how to solve equations. In this case, I give you the equation y equals negative 2x plus 2, but I tell you that x equals negative 1. This is a substitution problem. Anywhere I see x, I'm going to replace it with a negative 1. So I would write that y equals negative 2. Now I see an x, so I'm going to replace it in parentheses with negative 1 plus 2. From here, it's the order of operations. I have to multiply before I can add. So negative 2 times negative 1. Negative times a negative is a positive. 2 times 1 is 2 plus 2. So I get y equals 4. In this case, if I were to write this as an ordered pair, x is negative 1, that would be written first. Y is 4, that would be written second. That could be an ordered pair to represent a solution. Now, after today, there's a couple of different things that we'll need to know. First of all, when we talk about the solution to an equation with two variables, such as y and x, that solution is the set of any x, y combination that makes the equation true. So if my equation is y equals 3x, 1 comma 3 is a solution, because when x equals 1, y equals 3 in this equation. We can check that. 3 times 1 is 3. That's a true statement. So this is one possible solution to the equation. There are other solutions as well, though. In this case, negative 2, negative 6 is also a solution, because here x equals negative 2 and y equals negative 6. And if I were to check in my equation, negative 6 equals 3 times the x, which is negative 2, that's also true. So now we have two different solutions to that one equation. Can you think of any other sets of numbers, x comma y, that would also work? Go ahead and press pause, see if you can come up with a list of 2 or 3 of them, please. Okay, maybe you tried some of these. Here's the way I would go about looking to see if you can do this. Pick values for x. So I picked 0, 5, and 10. If x were 0, then 3 times 0 is 0. Y is also 0. That's a solution. If x were 5, 3 times 5 is 15. So y would be 15. That's a separate solution. If x were 10, 3 times 10 is 30. So y is 30. That's another solution. All of these, in this case 5 different ordered pairs, are solutions. There's many, many others. In fact, there's an infinite number of solutions. If we were to put all of those solutions onto a coordinate plane or onto a graph, the result would be the graph of that equation. For now, we're going to look at the equation that always form lines. Not all equations form lines. Some equations form different shapes. Our main focus in this chapter is going to be lines, though. So, if we go back and we look at the ordered pairs that we had, 1, 3, negative 2, negative 6, Well, we can start plotting those ordered pairs. 1, 3 is here. -2, -6 is down here. We have a list of others. These are the 3 I used. You might have others. I had 0, 0. I had 5, 15, but it doesn't fit. So there's no room for me to put that. 10, 30 doesn't fit. There's no room for me to put that. It doesn't mean those are not solutions. It just doesn't fit on this particular graph. Had we chosen, say, 2, 2 times 3 is 6, so it could have been 2, 6. 3 times 3 is 9, so if I had 3 as my x, it would have been 9 as my y. -1 would have been -3. -3 for x would have been -9 for x. What you hopefully see is that this forms, if we connect all of these dots, we have a line. Go ahead and draw that line in. I want to be able to point out to you, all lines have arrows on the end. Make sure you include an arrow that represents your line. Use a straight edge to make sure your line goes through those and is straight. You can use the side of your ID as a straight edge. The rest of the notes will continue on the next video.